As they chuckle in the background, right? Okay, maybe not so much. Maybe not such a good experience. All right, we'll pretend we didn't hear that. Okay, let's see here. Oh, it was the summer school. That's why, huh? Some of you, who took it in summer school? I know some of you go, okay, I'm so sorry. I really didn't have anything to do with it other than the fact that I said I'm not teaching summer school this summer, so. Okay, now they're mixing them up. Some are binary and some are ternary in this page. So everybody look at this page, whatever the number of this page is. Let me check and see what the page number is. So find this, it's the right below the section that you just worked on, page 5. All right, so look in the middle of page 5. It says, name the following binary and ternary ionic compounds. Now, they don't want you to just put binary and ternary in the blank. I have had students turn in this lab before, and they go, oh, well, that first one is ternary because there's more than 2. The second one is binary. The third one is ternary. The fourth one is ternary, right? No, that's not what you're supposed to do. What you're supposed to do is you've got to determine if they're binary or ternary in order to figure out how to name them, right? Now, these all have, or some of these have Roman numerals associated with them. So I'm going to have to put a little star next to the ones that have Roman numerals associated. But before we can do that, you got to know how you determine if Roman numerals are necessary, right? Okay, look back at your periodic table. And we talked about this earlier. You must use Roman numerals if it's not highlighted in yellow. I'm going to say that again, and you should write that down on your periodic table. Roman numerals are necessary if it's not one of these that's highlighted in yellow. So Roman numerals signify charges of metals. Those not yellow. Okay, so put that somewhere. You need Roman numerals that signifies the charges of the metals, and the ones you need to use Roman numerals for are the ones that are not yellow. So once again, to summarize, everything on the left-hand side of the stair step is a metal. We don't need Roman numerals for group 1 because they're always +1 when they make ions. We don't need Roman numerals for group 2 because they're always +2 when they make ions. And aluminum, zinc, cadmium, and silver are the only ones that have a single ionic charge. All other metals in binary or ternary compounds require the usage of Roman numerals. So put a little star right now next to the ones that you need Roman numerals for. So we're going to skip number 1 because it's that funky one with ammonium. Cr2O3. Look at that periodic table I just gave you. Does that one need a Roman numeral? Yes. Put a little star, next, like on the left-hand side of the Cr2O3. Put a little star there so you know you need Roman numerals. How about the CONO3 too? Do we need a Roman numeral there? Yes. Yes, we do. Put a little star next to that one. How about the CaCO3? No. How about the KCl? No. How about the FeSO4? Yes. Need a Roman numeral there, so put a little star there, right? You guys are getting the idea here? MgCl2, do we need a Roman numeral? No. How about the FeCl3? Yes. Yes, we do. Okay, so put a little star next to the ones you need a Roman numeral as you're going down. And now let's practice a couple of these, all right? I'm going to write a couple of these on my sheet here so that we can practice them. I don't have to flip back and forth. All right, so we'll do... Okay, I'm going to do 3, and then I'm going to turn you loose so that you guys can practice on this particular skill. So binary, remember, what are the suffix of a binary compound? IDE. Ternary compounds always end in ate or ite, depending on the polyatomic ion involved. So is this a binary or is this a ternary compound, this first one? It's a binary compound, right? What about this one? Ternary. And what about this one? Ternary. Okay. So we have to name this first before we apply the Roman numerals. The name of this thing, what's Cr? Chromium. And since it's a binary compound, we change the name of oxygen to what? oxide, right? We change the name, and we have to add the IDE suffix to signify that it is a binary compound. Now you kind of have to work in reverse to figure out what the charge on the chromium is, because we know that chromium can have more than one charge based on its position on the periodic table. It's not in group 1, it's not in group 2, it's not aluminum, zinc, cadmium, or silver, so we've got to attach a charge to it. So we have to work backwards. And we go, all right, well, I don't know the charge on chromium, but I do know the charge on oxygen. What's the monatomic charge of oxide as an anion? -2. If there's 3 of those -2 charges, this half of the molecule has to have what charge associated with it? -6. Did everybody see how I did the math there? Each oxygen is -2 based on its position in the periodic table. The subscript 3 tells me I have 3 of them. -2 times 3 is a -6 for that right-hand side of that molecule. Now I look and I say, all right, I don't know what the charge on chromium is, but I can figure it out because I know that all ionic compounds, and this is ionic because it's a metal and a non-metal, have to add up to 0. So if this half is -6, then the other half on this side must be +6, right? Because -6 and +6 have to balance each other out. Well, if this half is +6 and there's 2 chromiums, what must the charge of each of those chromiums be to add up to +6? 3. So the Roman numeral we're going to use, and you put it in parentheses. So there's the Roman numeral. And it signifies the charge on the metal. It doesn't tell you anything else. It simply tells you what the charge on the metal is, because chromium can be chromium +2 or it can be chromium +3. In this case, it's chromium 3. All right, let's do the next one. CONO32. What's the name of CO? Cobalt. Now we've got a ternary compound because I got this NO3 thing there. What's the name of NO3 as a polyatomic ion? Nitrate. All right, so there's the hard part, cobalt nitrate. Now I've got to determine the charge on the cobalt. So I look and I say, all right, I'm going to divide this in half. Each nitrate as a polyatomic ion, look at your list of polyatomic ions. What does the charge of a single nitrate have? -1. If there's 2 of them, 2 of those nitrate particles, that half of the molecule has to have what charge? -2. All right. If that half is -2, the other half must be +2. And since there's only one cobalt, what must that one cobalt's charge be? It must be +2. So then, our Roman numerals, we put a 2 and put it in parentheses.
Will that always work for you? Cross it like that?
And then you can crisscross and double check and make sure that you've done it correctly. So you can go back and you say, okay, if that's +2 and that's -1, yep, I'd need 2 of those, right? And this was +2 and that's -1, right? If you did the crisscrossing thing to check, it would still be the same, right? All right, let's look at FeSO4, okay? What's Fe? Iron. SO4 is sulfate. Okay, SO3, what's SO3 called? Sulfite, all right? So it's a little bit different. It's not sulfite, we're working at sulfate. Well, I don't know the charge on the iron, but I do know the charge on sulfate. What's the charge on a single piece of sulfate? -2, and I know there's only one of them there. How? How do I know that there's only one sulfate there? There's no parentheses, right? And there's no subscript outside the parentheses, so there's only one particle of sulfate there. If there's only one particle, that particle has a -2 charge. So then this half of the molecule must have what charge? Must be +2. And since there's only one iron, what must the charge of that single iron be? 2. There's 2 forms of rust. I think we talked about this. Right? 2 forms of rust. Okay, they're both called iron oxides. Are these binary compounds or are these ternary compounds? They're binary. And you know that because there's only two things in them, but they also have the IDE suffix. How am I going to differentiate the type of iron oxide that it is? What kind of iron oxide is this one? What Roman numeral would I use? 2, that's correct. How did he know that 2 was the correct Roman numeral to use? Oxygen's minus 2, right? So that means that half of the molecule is minus 2. This half has to be plus 2. There's only one iron, right? So that one iron must have a 2 charge associated with it. This kind of iron oxide, this is going to take a little more calculating, right? I divide it in half. What is a single ion of oxygen's charge? 2. If there's 3 of them, what does that make this half of the molecule? -6. If that half is -6, the other half has to be +6. Well, how many irons are there? 2. So if there's 2 irons and they have to add up to +6, what must each iron be? +3. See, we're having fun now. It's not such a mystery. All right, I'm going to let you guys work on that big honking thing.